Hi. We're going to move to section 11.5, which is talking about probability models. And really, what we're going to be talking about today is what it means to fairly choose, um, fairly make decisions, so as to not introduce any bias in a selection process. Our EQ is how do I use randomness to pick fairly? And that word random can be kind of tough to uh, to define or quantify, but we'll give it our best shot. Again, just kind of a multiple choice standardized test type question to get us started. So, as you may know, there's a lot of unnecessary information when it comes to standardized multiple choice tests. This has got 6 lines of text, and there's no way everything's important. First sentence: abandoned mines frequently fill with water. The second line before, or second sentence: before an abandoned mine can be reopened, the water must be pumped out. That's great. The size of the pump required depends on the depth of the mine. Okay, cool. If pumping out a mine that is D feet deep, so the variable D is going to represent depth here, requires a pump that pumps a minimum of D squared over 25 plus 4D minus 250 gallons per minute. Pumping out a mine that is 150 feet deep would require a pump that pumps a minimum of how many gallons per minute? It's such a ridiculous question. But basically what we're going to see is if we know that D stands for the depth of the mine and we are given a depth of 150, it's fair to guess at least that we need to plug in that number. So we have this expression D squared over 25. All I'm going to do is plug in 150 because that will tell me how powerful of a water pump I need to get the water out of this mine. Now, again, the context of this problem is a little crazy and has way more information than we probably need, but just again, trying to practice the types of things you'll be asked to do. So now that I have 150 plugged in there, there's a really cool feature that the calculator has where if I want to type in 150, I can do 150, hit this store button, this STO, and then hit the X button. This button right next to the alpha key has X, comma, T, comma, all this stuff. Basically just means the variable button. And then if I hit enter, now anytime I click this button, the calculator will put 150 in parentheses for me so I don't have to type all that. And what's nice about that is then I can just type out this expression using X. So X squared over 25 plus 4 times 150, which is X minus 250. And I get 1,250. And sure enough, that is an option on my multiple choice possibilities. So then D is the correct answer. Okay. So, this problem had basically half of its information was irrelevant. And the last 3.5 lines were all one run-on sentence. So really, to be successful on a multiple choice test like this, is can you cut through the noise and really figure out what you're being asked to do. Okay, so we're going to talk about fair decisions and randomness a little bit. We'll conceptualize at first, and then we'll actually put some math to it. If 3 of you are going to be chosen, so let's say just a class of students, let's say 35, 3 of you will be chosen to bring in treats for the end of the year party. Every student should have an equal chance of being chosen, right? That's what would be fair. And that's kind of what we mean by a fair situation, is that everyone has an equal chance of being picked. Students line up alphabetically, and each one in succession flips a coin. So 35 students each have a coin. The first 3 students that flip heads bring in treats. And the question is that a fair way of picking a student? And if you want, pause real quick, think about it, and see if you can come up with an idea and an explanation as to why. I'm going to argue that this is not fair because of this right here. If you're going to line up alphabetically and your name starts with an A, you're probably going to be flipping that coin. You're going to be one of the first 3 people flipping the coin, and you have a 50% chance of being picked if you flip the coin. On pun intended, on the flip side, if your first or last name, however you're being arranged, starts with the Z at the end of the alphabet, you, in all likelihood, won't even have to flip the coin because 3 people before you will flip heads. All right, so if we think, if there's just one person with each letter in a classroom, E, F, G, H, I, okay, what's going to happen is this person's going to flip a coin first, and then if they get heads, they have to bring in treats. Well, let's say just randomly it falls like this, right? That's not fair because none of these people down the line had to even flip the coin because 1, 2, 3 people before them flipped heads. So lining up alphabetically and flipping a coin, not a fair way to make a decision. Okay. Instead, how about this? I'm going to shuffle a deck of cards. There's 52 cards in there. And I'm going to give each person or each student a card. So you can pick the card from the deck. There's 52 to choose from. You have 1 card, so each student in the room has a card. Then what I do is I go take another deck of cards, shuffle it, and I start drawing off the top. And the first 3 people that match my card or match the card that I draw have to then bring in treats. Is that a fair way of picking students? We didn't even answer this. No. Alphabetical doesn't work. But if we look at this second example, okay, is it fair that everyone has a random card and then I go ahead and pick cards and whoever matches me then has to do it? Of course. I mean, the idea of being fair is does everyone have an equal opportunity or an equal probability of being selected? And in this case, yes, that is a fair way. Yes, every person has an equal probability of being chosen. So that's kind of an example of a fair example versus a non-fair example. What we're going to do is we're going to see how we can do this using numbers and mathematics. One last example quick. 2 siblings are trying to decide who has to watch their baby sister on Saturday night. They decide to race, and the winner does not have to babysit. Is the result a fair decision? Now, this we could actually have a discussion about. I would argue yes, because if both siblings agree to it, then they're accepting the outcome. Now, really the only way that it's truly fair is if both siblings have the exact same speed. And in all likelihood, there's an older sibling and a younger sibling. And between those 2, one of them's faster than the other one. And so that one's going to have a higher probability of winning. So there's an argument for that this isn't fair. But I would make the argument that if both students are say, you know what, let's do it, let's race, then it's fair because it's everyone, it's a 50-50 shot in theory. I'm going to just put you decide. Again, this is something that we'll maybe have a discussion on the day we go through this. So what we're going to, the mathy part of what we're going to do is we're going to introduce what are called random number tables, okay? And a random number table is just that. It's a set of random numbers. Now, these numbers are chunked into 5s, and the only reason they're chunked into 5s is so that they're easier to read. If all of the numbers were smashed together, it'd be kind of tough to see, what's going on there. And what we're going to do is basically to make this truly fair, in a given situation, we're going to assign a number to each person or to each option. And then we're just going to let the random number table decide, who gets picked, basically. So here's an example of how we'll do this. A coach wants to select 3 of her 15 players to lead warmups. How could a random number be used to choose the players? So what we're going to do is we're going to assign each person a number. So player 1, now I can't just call player 1 the single digit 1, because since I have more than 10, I need to assign a double digit number to each player. So what I'm going to do is player 1 is going to be represented by the digit sequence 01. Player 2, whether that's alphabetical or whatever, is 02, and then all the way down to player 15 is going to be 15. Okay, so each player has an assigned 2-digit number, and then what we're going to do is we're just going to use the random number table to create 2-digit numbers, and we're going to see who gets picked. Now, I will tell you that people do this differently. Some teachers do it differently than the way I do it. So here's how I interpret this. Okay, if I look at this table, the first 2 digits make the number 87. Is the number 87 assigned to one of the players on the team? The answer is no, because we're only going up to 15. What I say then is the next 2-digit number in this table is right there. If I, instead of 8 and 7, if I use 7 and 4, that gives me the number 74. Also not a player on the team. The next number would be 49, not a player on the team. 94, not a player on the team. I'm going to jump the gap and make 43 a possibility. Again, it doesn't really matter what you do because it's all randomly generated. But here we finally have our first player on the team that's been picked. So player 07 or player 7 would be the first person chosen. And I'm just going to keep going until I have 3 people on my team. So then if I cross the gap is 72, then 20, then 5. So there's player 2 that would have to, that would lead warm-ups. Then I have 52, 25. You can wrap from, you could do 51 if you wanted to. I don't love that. So I'm just going to restart the new and again, how you do this doesn't really matter. But the next number that'd be picked that's on the team is 14. So for this, now what I did is I went to the second line before when instead I could have just kept going across this way. But as long as you have some sort of systematic way of going through the random number table, it is random. As long as I'm not jumping to a certain set of numbers because I want someone to be picked. So 5, 7, and 14 would be the players that would have to lead warm-ups. 5, 7, and 14. Everyone had an equal chance of being picked, and so that's how we can decide. So if I use this in my pre-AP advanced algebra class, it look something similar, right? 35 students, so I number them from 0-1 up to 3-5, and then I have to decide the order of their presentations at the end of the try. Who are the first 5 students to present? So if I were to go through 87, 74, 49, 94, 43, 39. See, I'm just skipping over this until I get people that are on my class list. Then 20 is in my class, or the number 20 is assigned to someone in my class. 52, 25 is also assigned. So I would just keep this pattern going: 95, 57, 74. So the first 5 students that would have to present would be student 7, student 20, student 5, student 25, and student 4. Okay, so that's how we're going to use a random number table to make fair decisions on who has to or who gets to do a certain task. Okay, so how do I use randomness to pick fairly? We're going to assign a number to each person or option. Then use the random number table, random number, oh boy, random number table to select. Students or items. We'll just say items. Yeah, so it's kind of what randomness as far as probability is concerned. And then 11.6, we wrap up with some statistics talk.